Hey everyone, this is Vilas back here again from Selenium Express, and today we will be talking about one of the very important question called the difference between ArrayList and Vector. And to discuss this question, I have one of my friend with me. His name is Ashish. He's a real-time guy, and today we will be having a kind of in-depth conversation about the difference between the ArrayList and Vector. So before we get started, I just want to make sure, Ashish, right? This video is a kind of interview question and answer video, right? Don't take it like, it's a learning video. I mean, you can learn a whole lot of things over here, but if you want to learn some one-to-one thing, then I have already made some collection videos on ArrayList, on Vector. Those are available in my channel. I'll put the link in the description and they can go and watch that. But this particular video is pretty straightforward, and this is only we're going to make it for the interview purpose, right?
Yeah.
Okay, so that's the only thing that I want to say before we get started. Okay, so Ashish, right now you are comfortable, right?
Yeah.
So let's get started. So before we move into this video, and before we let me slow down a little. So before we move into this video and before we talk about the differences between ArrayList and Vector, first let's talk about the similarities, right? So what do you think about the similarities between the ArrayList and Vector?
Yeah, if we'll talk about the similarity between ArrayList and vectors, first of all, the both ArrayList and vectors are implementing the list interface.
Exactly.
Right, and both are coming under the collection hierarchy.
So the collection is kind of the root framework.
Yeah,
I mean, collection framework, under collection framework only, the list is coming, right?
Yeah.
And on list is the interface, and both ArrayList and Vector implementing the list interface.
Yeah.
Yeah, that's the first similarities. What about the behavior?
Behavior. Before that, I want to say one thing that whenever we want to represent some group of objects in a single entity, then we can use ArrayList as well as Vector.
Exactly.
So this is also one similarity we can say that.
Yes.
Right?
So the point is, like, if you want to represent a group of elements into a single entity, we can go for both ArrayList or Vector, right? So the thing is, the common behavior is going to be same for both ArrayList and Vector.
Yeah.
Okay, so now let's talk about some common behavior of both ArrayList and Vector. So let's talk about the insertion order, the inserting of duplicate elements.
Yeah.
It is different if you talk about ArrayList and Vector, or it is pretty similar.
Okay, Avilas, if you are talking about the common behavior of ArrayList and Vector, so there is one property, that is insertion order is preserved, right?
Exactly.
So
what do you mean by that? Insertion
order is preserved in the sense means if you are the way you are adding the elements. So during fetching,
it is going to display in the same way, right?
Same way we will able to fetch the elements.
Exactly.
So
the way we're inserting the element, the same way it is going to display the element.
Fetch the element.
Yeah. And it is irrespective of the ArrayList or Vector. The behavior is going to be same for both ArrayList and Vector, right? The insertion order is preserved. Point to note. This is the similarities, not the dissimilarities, right? Next thing is duplicates.
Duplicates, right? See, actually both ArrayList as well as Vector, internally it uses the index to store the elements. Index, that means index wise it is storing.
Yes.
So whenever if you'll add duplicate elements, it will accept the or it will store the duplicate elements, and we can distinguish between the duplicate elements by using the index, right?
Yes. So both ArrayList and Vector allows duplicates.
Yeah.
Right. That's the key point. That's the point that we are talking about, right?
Yeah.
Both the ArrayList and Vector allows the duplicates.
Yeah.
Right. Point number 2.
Yeah.
In similarities, right? Still now we're talking about similarities only. Okay, the next thing. So insertion order is preserved, duplicates is allowed in both ArrayList and Vector, and both are implementing the list interface. So this common behavior, these are some common behavior. Now let's talk about the dissimilarities, right?
And heterogeneous we can talk about, right?
Yes.
And both ArrayList and Vector, we can add heterogeneous elements, right?
Yes. So we can think like if we have a if we create a vector or if we create an array list, right? If we want, we can add integer, string. We can put any kind of objects there.
Yeah.
But make sure that
But that is not recommended.
Yes, that's not
basically
recommended.
in real-time requirement.
Yes.
We don't need this.
Yes. So basically, we need to make it typeset.
Yeah.
So just try using the generic. Try if you are trying to put the integer elements. make it an integer. If you want to put string, make it as string. If you want to make boolean, make it as boolean. Well, one more thing, we cannot add primitive to a list or a vector, right? We can only add objects, right? Like
but there is inboxing and boxing, right?
Yes.
So we can add.
Yeah. In that perspective, we can say that. But we can say whenever we are making it, whenever we are taking the generic type as integer or boolean, or let's say what we say double.
Yeah.
Those are objects only, right? We can only add objects to the collections, right? Not the primitives, right?
Yeah.
But as you said, there is a concept of boxing and unboxing, but let's for now, let's not talk about it. Okay. Let's not talk about it. Okay. So these are the similarities between the ArrayList and vector. So can we wrap it up, or is we?
No, that's fine.
That's fine, right? They'll be bored.
So more important thing is
dissimilarity.
Differences.
Yes. So whenever we talk about the differences, right? Here the fun part began, right?
Yeah.
It's not about saying in theory. It's all about how well we can prove it practically, and that's what we are going to do right now. And I'm going to ask Assis a lot of questions. And well, Assis, before we talk about the dissimilarities, right? Don't you think the search operation and the insertion operation, if you talk about an array list or a vector, if I'll give you, if my requirement is like I want to have, I want to use the list for searching operation.
Yeah.
Is it recommended?
Yeah, obviously, because see, in case ArrayList as well as vector, it is very fast in searching operations.
Exactly. Right.
As it is index based, right?
Yes.
So
yes. So I mean, if we want, let's say we have a very bigger list, right? Doesn't matter. Let's say we have a list of 1,000 number of indexes that we have. Doesn't matter if we want to fetch the 0th index or 10th index or 100th index or 1000 index. In a constant time only, we are going to get back the result. Right. So as you said, right, is index based, right? That's why it is pretty fast for the retrieval operation, for searching operation. So whenever your frequent requirement is searching, at that time you should go for the ArrayList or vector, right? Again, this is the similarities, not the dissimilarities, right? And well, how this searching functionality is getting pretty fast. It's index based, but there is one more common thing in between them. What is that?
What I know that both ArrayList and Vector is implementing one interface, that is random access interface.
Okay, can you tell me, in the entire collection framework, how many classes implements this random access interface?
I think only 2 classes.
These two, right?
These 2 only.
Yeah.
These 2 only implements the
random access interface, right? So both ArrayList and Vector, they both implements the random access interface. And this random access interface is a marker interface, right?
Yeah.
And what do you mean by marker interface?
Marker interface in the sense that is having no methods.
Exactly. So if an interface doesn't have any method, it's called marker interface. But this is off topic, right? I'll not ask you this question. Why we need a marker interface, right? Okay. If there is no method inside the interface, then why we need that? Okay, so let's not talk about it. Let's not go off topic. Okay, but fine. This is a question for you, right? Your interviewer maybe cross question you that, okay, what do you mean by marker interface and why do you want to use it, right? Yeah. Okay, so for search operation, these 2 are best. For insertion, these 2 are worst, right? Because, so why it is bad for insertion?
Because if you are inserting any elements in the middle, then it is going to shift the elements to next index.
Exactly.
So shifting operation.
Yeah, shift operation is there. And guys, if you don't understand this shifting operation, as I said, I already made a video about this access. The ArrayList video, you remember, right? They can go and watch that, right? Okay. You can get the link in the description or in the I button above. So because of the shifting operation, both ArrayList and Vector, they are bad.
Very slow in
performance.
Insertion.
Yes.
Operations.
When the frequent operation is insertion, this is bad, right? We don't need to use it. Yeah. I cannot say this is bad. It's based on the requirement, right?
Yeah.
So if my frequent operation is adding something into the last index, right?
Last index.
So
first index.
First index for fast also.
Okay. There is also shifting up operation.
I think for the last index, if you are adding, there will be no shift operation, right?
Yeah.
So it will be faster. But if you are adding something into middle, at that time you'll have the problem. Yes. So what you can do is, you can do some programs. You can calculate the start time, end time, do some operation, and find out the result, right? You can check. The linked list is pretty faster for the insertion operation, right? Obviously. So we can do some kind of experiment with linked list, ArrayList, try to find out the starting time, ending time, do your code over here in the middle, and just do some practical over there. Okay, come back. Let's come back to our topic, right? Let's not go off topic. Okay, finally, let's talk about the dissimilarities, right? Yeah. Let's talk about the differences right now. Okay, so before we move into the differences, do you want me to show them some slide, whatever we discussed? I think that's a good idea, right? About the similarities. So yes, so right now the slide is coming up. Okay guys, so right now let's talk about the differences between ArrayList and Vector. We have talked enough about the similarities as is.
Yes.
So now let's talk about the dissimilarities. I think everything is fine right now because we had some power issues in our room yesterday. So we had a long boring day today, but I think everything is all right now.
Yeah, fine.
Okay, so let's go for it. The first and the major difference between the ArrayList and Vector. Asis, let's start it. What is the major difference between the ArrayList class and the Vector class?
Yeah. So I will ask, if you are talking about the major difference between the Vector and ArrayList, so that is whatever the method inside the vectors are all synchronized.
Yeah.
Right. And whatever the method inside the ArrayList are not synchronized.
Exactly. Can you say all the methods inside the vector class is synchronized?
I think not all.
Yes, exactly.
Almost,
Remember,
we can say almost
Yes.
all the methods are synchronized
Because
inside the vector.
I found assist a lot of people in the interview. They say, yeah, every method inside the vector class is synchronized. But do remember it, not all the methods inside the vector class are synchronized. But well, almost most of the methods are synchronized in vector class. Yes. But right now, as you said, the ArrayList methods are synchronized, not synchronized. Sorry. I'm sorry. The ArrayList methods are not synchronized, but the vectors methods are synchronized.
Yeah.
So what do you mean by that synchronized method? So what actually the benefit or what actually the advantages of the synchronized method is good or is bad, or what is that?
Yeah.
Just tell me theoretically, right?
Yeah.
I don't want any practical programs over here, right? I'm not going to run any program. Just tell the viewers what do you mean by the synchronized methods.
Yeah. So what do you mean by synchronized keyword, right?
Yeah.
So in case multi-threading environment, if there is two threads accessing the same object, if it is synchronized, in case synchronized, it will not allow the two threads to access the same object at a time.
Exactly.
So it will the two threads will access the same object one by one.
Exactly. So, so as this, what do you mean to say that, if there is, let's say vector methods are synchronized, right? So let's say I have a vector object, right? I've created a vector object. So if I'm using any vector method, and let's say I have around 5 different threads. Threads means what? It's a separate flow of execution. All threads do some work, right? Let's say I have 5 different threads, and all 5 threads doing some work, right? So all the 5 threads, if they're accessing the vector object and they want to perform some task, they cannot do it, right? Because all the vector methods are synchronized. Not all the vector methods, but most of the methods for like adding and fetching and all this kind of operation, whatever the methods that we have in vector, they are synchronized, right? So if you want to perform those operations at the same time, you cannot do it because they are synchronized, right? So they should be happening one by one. So first thread 1 is complete its task, whatever the things it want to do with the vector object. Once it's released the lock of that particular object, then thread 2 will get a chance to do its operation over that particular vector object, right? Then once thread 2 is done, thread 3 will operate over the vector object. Like that, one by one the operation will be done, right? But what about the array list? If I create an array list object, right?
But whatever the methods inside the array list are not synchronized, right?
Exactly.
So in this case, multiple threads can access the same object at a time.
Exactly.
Right?
So as is synchronized, if we talk about in a very high level, right, in a multi-threaded environment, if our methods are not synchronized, right, there is a problem of data inconsistency, right? Okay, so that's why Java has given us this amazing keyword called synchronized. By using the synchronized keyword, we can make a object thread safe, right? If you are making an object thread safe, that means multiple threads cannot access that particular object in a particular time or in a same time, right? So vector are thread safe. Can I say that? And ArrayList methods are not thread safe.
Not thread safe.
Exactly. So this is the point number one. Most of the methods inside the vector class are synchronized, but methods inside the ArrayList class are not synchronized. Okay. So this is the point number one. Okay. So right now, as is the first point lead to us the second conclusion of this particular difference between ArrayList and vector. So in the first point, we have discussed that if our application is running in a multi-threaded environment and if we are using ArrayList, then multiple threads can access the ArrayList object in a same time, right? So performance will be slower or faster?
Faster, obviously.
Obviously, it will be faster, right? If there is a task and 5 people are doing that task at a time, obviously, the performance will be faster, right? But what about the vector?
In case of vector, all the methods are synchronized, right?
Exactly.
So in this case, multiple threads cannot access the same object at a time, right?
Exactly. Yeah.
So obviously, performance will be
slower. Think about that. The task example will be we have given, right?
Yeah.
There is a task. One person is doing that task. Then once he go away, the second person will go and do that task. Like the third person will go once the second person finish the task. So one by one things are happening. Obviously, it will be slower. The performance will be slower, right? So this is the point number 2. ArrayList performance is better
and vector performance is slower.
So ArrayList perform way better than vector, right, Assis?
Yes.
So that's the point number 2 that you have to remember and this is the difference number 2. ArrayList perform faster, vector perform slower. Okay, so as you have discussed in the last point, Assis, so if I know that I have a scenario and I have a application. If my application is going to run in a multi-threaded environment, if there are multiple threads, I know they are going to operate over my collection object, right? Then definitely I will go for vector, right? Because vector methods are synchronized
and it is thread safe.
But if I have a single threaded environment, then I will go for ArrayList, right?
Okay, I will ask, as a developer, if you are going to use this vector object or ArrayList object in your real-time project.
Exactly.
So, at what scenario and what object you will use? Can you?
Yes. So, as I can say for now, right? We are living in 2019, right? So, vector came in way back, right? So, I think the time when vector came back is in Java 1.0, isn't it?
Yeah.
So, so vector is a legacy class. This is also a difference, right? Vector is a legacy class and ArrayList came in 1.2 version. So when Java launched, right, particularly it came with some data structure like hash table, vector and all this, right? So if you see the vector class methods and that hash table class method, right, you can find that their methods are synchronized, right? So when Java launched, some people kind of think that okay, how their application, how their stuff is going to behave in a multi-threaded environment, but they found its performance is not better, right? So vector performance is not performing that good. So whenever when 1.2 version, right, in 1.2 version they have introduced the collection framework, right? When the collection framework launched, right, they have added a lot of new classes like ArrayList, HashSet, HashMap. If you see all these classes, their methods are not synchronized. So later these people, some people realized that no, we should be caring how my things are going to work in a single threaded environment, and if there is a situation, right, that you have to go for the multi-threaded environment, how your application is going to work on that, then we have some support. We have some method in the collection util classes. What is that? Synchronized list, right? We have some methods like synchronized list, and in 1.5 version also they have introduced this concurrent package, right?
Concurrent package, yes.
CopyOnWrite ArrayList, right?
CopyOn.
We can use those stuff. So why I'm saying all these things is, so if you talk about this vector, right? It's a legacy class. This came in way back in 1.0 version. Is have its own con and pros, but basically this class is not that's stable right now. I'll say it's a little broken, so I'll be definitely go for ArrayList, right? So yes, I'll use the ArrayList for the multi-threaded environment, but as we said, ArrayList methods are not synchronized, so we have to make it synchronized, and for that, these Java people right now have a support, right? For they have already inbuilt method. We have to just create our ArrayList object, ArrayList list equal to new ArrayList, then put that list object inside this collection util dot synchronized list method, right? Then our list object, it will become synchronized, right? Or we can also use the CopyOnWrite ArrayList class, right?
Yeah.
So CopyOnWrite ArrayList class came in Java 1.5 version, and they have given this class, to support. If you have a requirement, if your application is going to be in a multi-threaded environment, then use this CopyOnWrite ArrayList class, right?
Yeah.
This is also going to make your
internally Java itself is handling the how it will make the
object thread
set.
Exactly. So
no need to handle ourselves.
Yeah,
the developer.
exactly. Yes.
So that will be very good, right?
Yeah, obviously. So because JVM is handling all these things, right? So yes, answering to that question, I'm not going to use vector object. I'm not going to depend on or rely on the vector class. I think vector class is kind of used by student right now. It's not for the programmers these days. So I will use, it's my own opinion. I'm going to use the ArrayList class, and I'm going to use the collection class methods to make it synchronized, or in a better case, I'm going to use the CopyOnWrite ArrayList class.
Yeah.
CopyOnWrite ArrayList. It's a big name, weird name, but does better in multi-threaded environment, right? Okay, so yes, that's the answer to your question. Okay guys, so right now as you have discussed about the CopyOnWrite ArrayList, which is gonna be useful whenever we are going to work in the multi-threaded environment, as we have discussed these things. So right now from this thing, okay, as is CopyOnWrite ArrayList, right? And CopyOnWrite ArrayList is also implementing the list interface, right?
Yeah.
the ArrayList property and CopyOnWrite ArrayList property, most of their properties same, right? Duplicates are not allowed, insertion order is preserved, the way you are going to insert, the same way it is going to display, right?
Yeah.
Almost every property is the same, but if you talk about a multi-threaded environment, how the ArrayList object is going to behave and how the CopyOnWrite ArrayList object is going to behave is different, right?
Yeah.
As you have said that ArrayList object are synchronized or not synchronized?
Not synchronized.
Not synchronized. So multiple thread can operate over a ArrayList object in the same time, right? Okay, now this is a challenge for you. Okay, let me ask a tricky question to Ashish. It's not tricky for him, but let me ask it. Ashish, now think that I have a ArrayList object, ArrayList list equal to new ArrayList, okay, and I'm adding few names to my ArrayList. Let's say ArrayList.add of Ashish, ArrayList.add of Rakesh, ArrayList.add of Sumitra, and I have added few elements to my list.
Okay.
Now let's say I have two different threads. Okay, I have thread 1, I have thread 2. The first thread is doing what? It is fetching all the elements from the list. It is just iterating over the ArrayList object, and it is printing all the names to my console. It is basically thread 1 job is just basically reading all the elements from the list, right?
Okay.
And there is a thread 2. The thread 2 is adding something in the middle of the list. It is basically updating something. Okay. Let's say in the index number 1, it is adding some new value, some new name. Then what will happen? It is not thread step, right? So both the thread is going to operate over that particular object, right? One thread is fetching the thing. One thread is adding something in the middle. What will happen? And can you give me an example? What will happen in this scenario?
It's really a good question. I will ask, and the answer is definitely it will give us a exception, that is concurrent modification exception.
Exactly.
Right.
Yes. But
because see, suppose there is what you did, you create an ArrayList object and you added some elements, right? Suppose 5 elements you added.
Exactly.
5 elements, suppose Rakesh, Abhilash, Ashish, something is there.
Yes. So I've added 5 elements to the
list. So
one
thread is trying to fetch the elements, so it will not give any problem.
Yes.
So if another thread is trying to update the elements, update any whatever
index value you are saying,
elements are there, if it is trying to update that means the structure of that object is changing, right?
Structure of ArrayList object you are saying.
Structure of that object is changing. So definitely it will give the
so if you talk about a ArrayList object, Okay, if we are making any change, any structural changes to that ArrayList object or that array, right?
Yeah.
So ArrayList is basically uses an array in the backend, right? The way ArrayList store elements, it is basically uses an array which is a growable array or what do we say that? Growable array or resizable array, right? It automatically grows, right? So if I'm adding something to my list, and whenever one thread is iterating some element from that array, and another thread is just adding something in the middle, so the array list,
you are updating.
Yeah, that array structure is changing, right?
Yeah.
So we are making a structural change to the existing array, and at that time
you will
it is going to fail, right? But can you tell me it is going to fail every time?
No.
Exactly.
Because
it's not going to fail every time.
Yeah, because if you add to the end of the object, then it will not give any.
Exactly. Structural changes means
you are doing some updating operations.
Yeah, exactly. You are just modifying something which is already there.
Yeah.
Right. Adding means you are adding something to the last index of the list object, right? Okay, so Ashish, this is confusing, right? I think now we only understand what we are basically talking. Let the viewer understand also. If somebody having a student or a fresher is also watching this, I want them also to get it. Well, if you are not getting this point, if you do not know multi-threading, don't worry, right? Why we are discussing about this thing, Ashish? Because the difference between ArrayList and Vector is really simple, right? Anybody can answer it.
Yeah.
But whenever you go to a job interview, they are going to cross question you, right?
Yeah, obviously.
So at that time, it is going to be a problem. So I'm not going to get into the threading concept a lot right now, but I want you, Ashish, to write a program and show me, right? Create two different thread. Let one thread fetching the things, let one thread adding something in the middle, and let's see in which situation we are getting exception or we are not getting exception, and how to make it thread safe by using the Copyonwrite ArrayList class, which is provided by the Java people in Java 1.5 version. So let's do a program. That's it, coming up right now. Alright guys, so right now you can see over here I have a class here called ArrayList demo. In this ArrayList demo class, I have a main method, and in this main method first I'm creating a array list, right? So in this list that I'm creating, I'm going to store a bunch of string. Okay, so I'm basically going to store some names in my array list. So here I'm adding few names to my list. So I'm going to use add method, and I'm going to add Ashish, Avilash, Rakesh and Frank to my list, right? So in my array list object right now, there are 4 names present in my list. So right now what I'm going to do, I am going to create a thread, right? So as I said, I'm going to create 2 different threads. The first thread is going to fetch the element from this list, and the second thread is going to add something in the middle of the list, right? So let's implement it practically. So first of all, I'm going to create a thread. So how to create a thread? Okay, I know that if you are knowing multi-threading, you already know about how to do that. But I'm going to tell you a new approach here. I'm going to directly do it over here. So I'm going to write new thread. So it's a shortcut approach. I hope you know it. If not, now it's a time to know it, right? So I'm going to end it over here by putting a semicolon, and I'm going to override the run method over here as well, right? So now you can see this is a thread I've created. So if you are seeing it for the first time, I know it's a little surprising for you, but this is an anonymous way to create a thread. So let me remove this run method because I don't want to call the superclass run method. So right now here I'm going to do what? Let me give a space, and I'm going to say I'm going to fetch the elements from the list object, right? And my list object is what? This has all the names, right? So let me fetch it from here, elements. Okay, so now let's implement the things that we have discussed right now. So which is my collection? This is my collection. Let me copy this name, let me paste it over here, and let me say iterator. Okay, so why I'm running the iterator method over my names? Because I'm going to iterate over all the elements which is present inside this name. Ashish, Avilash, Rakesh, Frank, all these things I want to iterate over one by one, right? So this is right now going to hold a bunch of names. So if I'm going to put my crossover here, so you can see that it is going to return me a string of iterator of string, right? So let me store it with a iterator iterator, where are you? Okay, and it's going to return me a bunch of string, let's say collection of names, right? All right, so right now this collection of names does have all these particular names, right? So right now I'm going to check while there are names present with this particular collection. So control V, while this collection has elements or has next, means it is going to check whether this particular collection has names. At that time I'm going to print out that name. So I'm going to say collection, if there is name, then give me that name, and I can do that by using this next method. So this next method is going to give me a string back. So I'm going to hold it over here, temp name. Okay, and there you go. And right now I'm going to print it, temp name here. Okay, so that's done, right? So right now what I'm basically doing over here, I don't need to tell you that, I know you already aware about the cursor, how the cursor concept works. So this is basically going to work like a for loop. It is going to iterate over this names variable and going to print all this name one by one. So right now I'm going to start this particular thread. So how I'm going to start this? So to do that, I'm going to write thread, and I'll give it a reference, and I'm going to do what t1.start method, right? Or else there is another shortcut to do it. Let's not do in this way. We can also do it in this way, right? I can do what? Let me go back to here, and here I can say dot start. There you go, right? Pretty readable code. Maybe for the first time if you're seeing it, it's a little confusing, but I think it's very straightforward. Just pause the video, watch it for a few minutes, and you will be all good, I know, right? Okay. So right now what I'm going to do, I'm going to create another thread. So I'm going to do a new thread again, and here I'm going to open it and close it, and okay, so it's already done. Okay, so now I'm going to end it with a semicolon, and here I'm going to override the run method, because if I want my thread to do some job, then I have to put it inside the run method, and I don't want this dummies over here. Let me remove it, and again I'm going to say this thread job is adding an element to the middle of the list, right? And here what I'm going to do here, so let me say which is my collection object. My collection object is names, right? Let me copy this and let me come over here, let me paste it over here and say names dot add, and here I'm going to add the element which is, let's say, done, and I want to add this done to the first index, right? So there you go. Now this will cause the problem. This is our problem statement, right? Problem statement. So what will happen right now? Okay, so let me start this thread as well. So dot start, dot start. Okay, so right now what I can do is I can run this particular program. So here I have it's a very simple program, right? So I have basically created a array list, then I've added few elements to my list, then I have two threads. The first thread is actually, it is iterating over this particular list object, and another thread, this one is basically adding something to the middle of the list, to the middle of this particular array, which this one is using in the backend, right? So let me right now run this particular program. So what do you think? We're going to get an exception or not? Well, we cannot predict because this is a multi-threaded program. Let me run it, and there you go. So okay, so right now in this case we are not getting any exception. So the reason why we're not getting any exception is first this particular thread is getting executed, and then this is getting executing. So once the iteration is done, after that only it is trying to add, so there is no problem. So the problem will occur when we keep iterating, in the same time only this is going to add to the first index. So looks like this thread is executing first, and once it is done only this is executing next, because it's multi-threaded program. We never can guarantee what is going to happen. So let me put a sys out over here. So let's say sys out, and let me say adding done to the list. Now let's see where this particular line is coming right now. Okay, so let me run it again, and there you go. So now you can see first this particular thread is getting executed, and once this is getting completed, this is getting the chance to get the execution done. No, I want first this thing to be done somewhere in the middle, right? So let me execute some time more, and this time also you can see. So now you can see this debug line is coming after it finishes iterating all these elements. So let me run it again, and let me run it again. Okay, so there you go. So now you can see it's adding down to the list. Okay, so somewhere whenever this is reading it, at that time only it is adding to the middle, right? So we're getting this concurrent modification exception because two threads get executed, and while this is trying to read, at the time only it's adding somewhere in the middle, right? And we are having the problem. You're getting it? So if I run few times more, you never can predict that we are going to get an exception or not. But this is a problem statement. This is going to cause you bug in your production, right? So ArrayList is not safe in a multi-threaded environment. So let me keep doing it for a few more times. We will see some more exception will come. So let me get a situation like this. Okay, so here we go. So right now this is again a problem situation. Now you can see adding down to the list. So now somewhere while it is reading the elements, at that time only it is adding to the middle of the list. So the array structure is changing, and once the array structure is going to change, it is going to throw you a concurrent modification exception. So we're going to talk more about this concurrent modification exception more when we'll have some future tutorials. But for now, you think that this iterator, right, this iterator that you are running over a ArrayList object is fail first. So that means, what do you mean by a fail first iterator? So remember this thing, ArrayList iterator is fail first. The fail first iterator means whenever the iterator is reading your list object, at that time if you are making any changes to your list, if you are making any structural changes to your list, it is going to throw you an exception called concurrent modification exception, and we call it fail first because the moment it is going to find that your array has been modified, at that time it is going to throw you an error and say, "Boss, I cannot do it. I cannot do this. This is not safe. Why you are adding when I am actually iterating over this names object, right?" I think I am clear. I am a little clear for you right now. That is enough for me, right? We will talk more about this in the future tutorials. And I just want to tell you one more thing, that now you might be thinking, okay, how actually this iterator is knowing that, well, there is a structural changes. So the way this iterator is knowing that, okay, there is a structural changes made to the existing array that I am iterating right now, the way this iterator finds it, because this iterator internally uses a flag, there is a boolean flag, is a boolean variable is uses, and that boolean variable is by default false. But whenever we are making any structural changes, whenever this iterator is actually iterating over this particular elements, but we are making a structural changes in between to this particular array list, at that time that particular flag becomes true, and this guy will know, okay, right now somebody has changed the existing array that I am iterating to, so it's time to throw an exception because I am fail first. And fail first mean the moment my array will be changed, I'm going to throw an exception, and that's the concept that you have to understand. So right now I think you got it, why ArrayList is not safe to use in a concurrent environment, right, or in a multi-threaded environment, because there is a chance of data inconsistency, there is a chance of as this iterator are fail first, and there is a chance of getting exception as well. So we'll talk more about it, but right now let me switch to the CopyOnWrite ArrayList so that I can show you right now this particular problem is not arising during when we're using a CopyOnWrite ArrayList instead of a ArrayList. So let me switch to that particular program. So guys, this is basically the same program that I have written over here. So instead of the ArrayList, so this is the previous program that we have done. So here instead of the ArrayList, I have taken CopyOnWrite ArrayList, right? So this is the particular class which has been given by the Java people in the 1.5 version, and they said, okay, well, if you have multiple threads to operate on, then please use this particular class, because this iterator that you are using, the CopyOnWrite ArrayList iterator, is fail safe. This is not going to throw you an exception immediately, right? This iterator is fail safe, right? So if I am putting a debug line over here, let's say adding done to the middle of the list, right? This is basically the same program. We have two different threads. This is basically fetching the elements. This is actually adding something to the middle, right? And here we are using CopyOnWrite ArrayList. So let me do a right click, run as Java application, and there you go. It's adding done to the middle of the list. We have already seen this kind of scenario in the ArrayList. It was not failing. We are going to specifically observe when this is coming inside middle or in the first. I want this operation to be done when somewhere this particular thread is also running. When this particular operation is happening, whenever the iterator is running, somewhere in the middle, I want this to be done, right? So let me keep executing this particular program. Let me wait when the adding done will come first or in somewhere in the middle, so that I can make sure that the done object is getting added while there is a iteration going on. So let me wait for that scenario when it is coming. Well, come on, man. It's a multi-threaded environment. It's a multi-threaded program. This is not in my hand. This is not in my control. So even you know it, but I know we are not going to get any kind of exception during this scenario, right? Because we are using a CopyOnWrite ArrayList. But I want to show you that scenario because we are getting exception in the earlier cases whenever we are using ArrayList. But now let me keep on executing the program. Whenever adding done, we will come at the middle or somewhere in the middle. So let me keep doing it for you guys. Okay, so here we go. So right now you can see the scenario, right? So we're adding done somewhere here. So we can assume that this is the statement, right? So we don't know when it is adding, so it might be adding somewhere whenever the iteration is going on. So right now we can see that it is not throwing us any concurrent modification exception. So that is the point that I want to prove. So in a multi-threaded environment just like this, try using CopyOnWrite ArrayList because this is more stable, and this is the class you can rely on, right, when it comes to a concurrent environment. So that's it. So right now let's go back to the discussion. Okay, so right now we have talked enough about the synchronization and all those stuffs. We also discussed about ArrayList is not legacy, vector is legacy. But apart from that, let's talk about some other differences, right? Yeah. So is there any other difference between ArrayList and vector?
Yeah, there is one more difference is there, that in case memory consumption, right?
Exactly.
Suppose you are creating the ArrayList object and you are creating the vector object. So how much memory is allocating to the vector whenever you are creating? Yes. How much memory is allocating to ArrayList object?
Yes.
So there is difference.
Yeah, there is a difference within that. Yeah, that's the point, right?
Yeah, that is.
Once you tell all these things to the interviewer, the next thing he's interested about is this thing. What is going to be the capacity? What is going to be the size?
Yeah,
right.
Yeah. Capacity. Yeah.
Exactly. So Ashish, can you tell me? Okay, let me come back to this capacity point, right? So when we create an ArrayList object, internally actually what happens?
Whenever we are creating the ArrayList first time, then the default capacity is there, that is 10.
Exactly.
It is.
It's called the initial capacity, right?
Yeah.
The initial capacity or default capacity. The capacity of ArrayList is 10, right? Okay. What about the vector capacity? Whenever we create a vector object,
the same. I think same.
It's going to be 10 also.
Also 10.
Okay. So now here is a tricky question for you. Okay. So as you said, the initial capacity is 10. So if I'm creating an object like ArrayList list equal to new ArrayList.
Okay.
What is the initial capacity right now?
Same 10.
No. Yeah, I agreed with that point.
Okay.
But in the same time, Ashish, when we create the ArrayList object, at that time the initial array which is created in the backend or in the background, what is the arrays Java is using to store element, that array capacity is gonna be 0. it's gonna be 0 only. But whenever we are adding element to that particular array, so right now let's say array is created.
Okay. Got it. That means whenever we are creating first time,
Yes.
it is 0. The size, the capacity is 0.
Exactly.
Whenever first time we are adding any element,
Yes.
then it will become the 10, right?
Yeah. That's what I'm saying. So what I meant to say, whenever we are adding the first element to our array list,
Yeah.
at that time the array got initialized and the size become 10. Yes,
Okay.
the array initial capacity is 10 only, right?
Yeah.
But is whenever we are
Yeah, that
creating
is-
the object, at that time it is not becoming 10. But I think in the earlier version of Java it was there. But right now in the newer version of Java, first time you are adding an element to the list, that time only it's becoming 10.
Yeah,
right?
it is also good in performance, right?
Yes.
Simply, if you will create any object and if we are not using,
Uh-huh.
then why the capacity will be 10, right?
Yes, exactly.
Right.
Yeah, that's the point. Okay, and what about vector? Vector is also initial capacity is also 10,
same.
right? Okay, now another question for you. So let's say I have created an array list.
Okay.
Okay, the initial capacity is 10.
Okay.
Array list has created a array in the behind. Then we have added 10 elements to the array list. Now the size of the array list is full.
Yeah.
So whenever I'm adding the 11th element, what is going to happen?
So you know already that it is a resizable array, right?
Yes.
Internally it is using.
Yes.
So it is going to resize the array object.
Yes.
Means it will increase the capacity of that object.
Yeah. So by how much factor it is going
Yeah,
to?
actually there is some rules. In case array list,
Mhm.
it is going to increase the capacity by 50%.
Exactly. Yes.
And in vector, it is going to increase the capacity by 100%.
Okay, so now Ashish, okay, now
So
coming back to, so now let's come back to this point. Let's make it simplify, okay, because I don't want to confuse people. Let's say I've created a array list, right?
Okay.
The size of the array list right now is 10. I have added 10 elements to my list, right? So my array list is full right now. So whenever I'm adding the 11th element to the array list, as I said, it is going to increase the capacity by 50%.
50%.
Okay, so initial capacity was 10.
10.
10 50% is what?
5.
5. 10 plus 5 is what?
15.
15. So 15 is going to be the size
So
of the
next capacity.
next
will be-
capacity. So what will basically happen? So whenever the array capacity is full, it is internally creating a new array,
Yeah.
right? And copying all the array element.
New.
Yeah. All the what is the old array we have, whatever the old array element we have, those element will be copied to the new array, right? And the
Having
capacity of the new array will be 15.
Yeah.
Am I correct?
Yeah. Obviously.
10 then 15. Okay, what will be the next size? Let's say I have a old array, capacity is 10 is full, then 15 we are creating.
15 means 15 again 15%. Sorry, 50%. So let's talk. Let's
Let's say 15
7.
Yeah, 7.
Add 7.
Then 50% is 7. 15 plus 7
not
is
not exact.
yeah, 7, right?
Okay.
15 plus 7 is what? 22.
22.
So the next size will be 22. Once you have 15 elements in the array, the next size will be 22, right? Okay. But what about vector? Let's say I have created a vector object. The initial capacity of the vector is 10, right? So I have inserted 10 elements to my vector.
Okay.
The next time whenever I'm adding the 11th element to the vector, what will be the size of the vector?
It will be 100%.
Yeah.
Right.
Yes, 100%
So
means
if it is 10 means
Uh.
the next capacity will be 20.
exactly 10 plus 10 is 20. Okay, Ashish, right now this is again very theoretically we are saying, let's prove it with a program, right? So let's do a program about the size and
You can debug, right?
yeah, we
You
can debug
and see
yes,
that.
yeah. So yeah, let's debug it for 5 minutes now.
Okay.
Okay,
fine.
we can
Sure.
debug it for 5 minutes and let's see now what is happening internally in case of ArrayList and Vector whenever we're dealing with the capacity, right? Okay, so right now Ashish, let's go ahead and let's do that capacity program. Let's see how the ArrayList capacity is getting calculated, how the vector capacity is getting calculated. Is this exactly raising it by 50% as we have discussed in the theory or not? Let's prove it practically, because this is the program I found sometime they ask in the interview, they will tell you, okay, prove it. Okay, so let's prove it right now. Alright guys, so right now this is a very simple program that I have already written here. So let's try to understand what I have done here. So it is very simple. So I just have a class here called ArrayList demo and no need to extend thread. I'm sorry, let me remove it. Okay, so this is just a very simple class called ArrayList demo, right? So this particular class has a main method And in this main method, what I'm doing is, first I'm creating a ArrayList object which is of string type, and then I keeps on adding few names to my list. So basically I've added 10 elements over here to my list, and this is gonna be my 11th elements, right? So we are going to observe here. So here we are creating our list, right? Here we are inserting our first element. So I'm going to see, I'm going to give a breakpoint here, and I'm going to see whenever I'm creating the ArrayList object, what is the initial capacity, and whenever I'm adding the first element to my list, at that time it is getting initialized, or it is getting initialized in this stage, as we have discussed in the a few minutes back we have discussed about it, right? So let's prove it practically, and then we are going to keep on adding around 10 elements to our list, and once our list is getting full, we'll try to add the 11th element, and we're going to see that a new array is getting created with a new size or not. So I'm going to put another breakpoint here. So this is going to be my 10th element. So I'm going to see while we are inserting this particular element to my list, and I'm also going to see what is going to happen here. So I have given 3 breakpoints here, right? Alright, so right now I'm going to debug it. So I'm going to do debug as sub application, and let me click yes, and well, there you go. So right now my program execution stops here in the line number 16, and as you can see in the line number 13 we have already created a ArrayList object called names, right? So this is my ArrayList object called names, and you can see right now this is an empty array, right? So as of now it is not initialized yet. So we have already discussed about this few minutes back. So the array will be initialized once we are going to add this particular element to our list. Right now we have not yet added this element, right? Our program execution right now stops here. So we are about to add this particular element right now, but before it, so this is the object array, its size is 0 right now, and there is no elements entered to my list, so the size is 0. The size is basically how many elements your list has, and this is basically that array, what ArrayList uses to store all these elements, right? So this is basically that array, right? So right now I'm going to add my first element here. So I'm going to click on F6, or I'm going to click here step over. So right now you can see the object, this particular array is initialized to 10. So right now an array has been created with 10 number of indexes, and first we have entered Abhilash. So Abhilash comes here, and our size of the array is right now 1. So right now we are going to insert a few more elements to our list. So let me add Ashish. So Ashish got added over here. So let me add Rakesh. So F6. So Rakesh got added over here. Like that, let me come till this point so that my array will be full. So you keep on looking here and looking here. Let's see how our objects will be added here. So right now we have added Ashish again, then Rakesh. We're going to add over here. Let's add Abhipsa, Abhilash, and Ashish. Okay. So right now, right now we have added the elements till here, right? So till Abhilash we have added the elements. So right now our array size is 9. Okay. So let me add the last element Ashish, so that our array size will be full. So let me add this one. So right now you can see the size of the array is 10, right? My array is all full. So right now if I'm again going to add this element Ashish here, there is no more space left with this old array. So right now internally it is going to create a new array, and what is going to be the size of that array? So right now you can see the size of this particular array is 10, but the next size will be, as I said, it is going to increase by 50%. So 10 50% is 5. So 10 plus 5 equal to 15. So as soon as I'm going to insert this particular element, you can see the size will be increased to 15 here. So let me hit F6 and keep your eye over here. So if I'm going to hit F6 here, I can see the size is inserted to 15. Sorry, the array, a new array has been created with the size 15. So if I'm going to scroll over here, you can see it's a new array. We got some more spaces over here, and right now the Ashish also got added, right? So that's how these things are working internally, and the things are getting added over here, and the memory management happening in this way. Okay, so right now let me stop the execution. You already know about it, and sometimes your interviewer might ask you, okay, so what is the formula that ArrayList uses in the behind, to determine the size? So this is basically the formula. So let me show you this formula. So this is the formula that ArrayList is using internally to decide the next size. So this is going to basically increase your size by 50%, right? So don't be get confused by looking into this. So if you are not able to calculate this operation, so what we can do simply sys out, right? So let's see this formula is correct or not. So old capacity, let's forget about the old capacity, let's focus over here right now. So what is my old capacity? My old capacity is 10. So, and then I'm going to put this right shift operator, and I'm going to put 1. Let me see what is the value of this is coming, then I can add that result to old capacity, right? So if I'm going to run this particular program, so let me click OK. So now we can see the value is coming as 5. That means this particular value is 5, and old capacity was, the initial capacity was 10. So 10 plus 5 is 15, right? So this is the new size of the array, right, that we have just seen. So right now you know what is basically the formula that ArrayList is using in the behind to determine the new capacity of the array, and that formula is this one. So this particular formula introduced in Java 7. So from Java 7 only, this is the formula which is getting used internally by ArrayList to determine the new capacity. Previously the formula which was being used was this one, right? So this formula gets used till Java 6, but from Java 7 they are using this one, right? So previously old capacity into 3 by 2 plus 1, this is the formula they are using till Java 6, and after Java 7 they switch to this, right? So this is basically increasing our list capacity by 50%. This is clear. Now let's talk about the vector. Alright, so right now this bunch of code we're going to see that how a vector is increasing its capacity dynamically. So first of all, here I'm creating a vector object, then I keeps on adding 10 elements. So we know that the vector initial capacity is 10, so I've created an empty vector, then I have added 10 elements to my vector. Right now if I see the capacity, obviously it is going to show me as 10 because the vector current capacity is 10. And so here what I did, I basically used this function called capacity from vector class, and I stored it with a variable called current capacity, and I'm printing it, and the value for this obviously will be 10. And after this I'm trying to add the 11th element over here, and right now what I'm going to do, names, which is my vector object, then I'm using add element method. I'm adding another string to my vector, let's say Ashish, right? And now again I'm trying to check the capacity. Right now already the vector size was 10, so it was full. So when I'm adding the 11th element, again the capacity will be increased by 100%. So the previous capacity was 10, then again it is going to increase by 100%. So 10 plus 10 will be 20, right? So whenever I'm using this particular method, storing this particular capacity here, and I'm printing it again, I am damn sure that I'm going to get the capacity as 20 here, right? So let me run this particular program and let me check this out. You can see till here the capacity was 10, but the time I've inserted the 11th element to my vector, then the capacity became 20, right? So these are some existing functions that you can use to check the vector capacity, and that's it for now. Okay, so right now let's talk about another difference between ArrayList and vector assist. Okay, so before we go forward, assist think like if I have a collection. Okay. In collection, the name says everything, right? In collection, what we store? We store a group of elements, right?
Yeah.
Let's say I have a collection object, and in that collection object, obviously a group of elements are getting stored, right? I have a collection object, and in that collection object, I have a lot of elements, and I want to fetch every element one by one. Mark this word, one by one. I want to fetch these things. So what you will use?
We can use iterator class.
Exactly.
That is an interface, right?
Yes. So iterator is not a class, right? It's an interface.
Yeah.
So okay, so if you talk about iterator, right? Okay, how many types of iterator that we have?
Iterator, list iterator, right?
And enumeration
And
also.
enumeration also.
So as you said, iterator, list iterator, and enumeration, they all are interfaces, and they have specific methods, and their methods has been overridden in your class, like in your ArrayList class or your vector class,
Yeah.
or in your linked list class, and accordingly the implementation is there. Basically, iterator, or list iterator or enumeration, these things basically help us to get things one by one from the collection.
Yeah.
I have a box of chocolate, and I am getting all those chocolate one by one. Okay, so that's why iterator, list iterator, or enumeration getting used. If I not use iterator, is there any other way you can fetch everything one by one?
Yeah, we can use for loop, right?
Okay, yeah, a fresher level question, right? I shouldn't ask you this. Okay, so for loop we can also use for that. Okay, so now let's say, now I'm going to confuse you. I'm also going to confuse you guys also. So let's say, but I know you are not going to confuse. So think like I have a ArrayList object,
Okay.
right? Okay, so I have a ArrayList object. Okay, so can I use the iterator with my ArrayList object?
Yeah, obviously.
Can I use the iterator with linked list object?
Yeah.
Okay, can I use the iterator with hash map?
Yes.
Okay, can I use the iterator with hash set?
Yeah, obviously.
So what is the conclusion?
Iterator is the interface that we can use with all the collection implementations, right?
Yes, with everything which is present inside every classes which is implementing the collection interface, we can use the iterator,
Yeah.
right? To fetch element one by one. Coming into play, can I use the iterator with vector?
Yeah, obviously. Why
Exactly.
not?
Yeah.
Are you thinking that vector is a legacy that we are not able to use the iterator also, right?
No, that is my question.
I think no, it
Okay.
is not. Because
So-
vector is re-engineered to the collection hierarchy, right?
Exactly.
That's why we also can use the iterator
With the vector
with the
class.
vector class.
Yes. But if you talk about very specifically, enumeration is very legacy, and enumeration is specifically designed to use it with a vector object, right?
Yeah.
So we can use enumeration or iterator to fetch element one by one,
elements.
one by one using a vector object, right?
Mm.
Okay, so what is the conclusion?
So in case vector, we can
Yes.
use both enumeration as well as iterator, right?
Yeah, vector we can use either enumeration or iterator. That's the thing. Print it in your mind, otherwise don't be confused with this. Okay, so right now let's talk about enumeration, right? Enumeration is specifically designed for vector,
Yeah.
right? Can I use enumeration with a ArrayList?
No,
Okay, why
it will
not?
give error because see,
Yeah.
it is legacy and it is not able to. We cannot use it to collection hierarchy, right?
Exactly. So enumeration is specifically designed for
For the
vector, right?
legacy classes.
Yes, for the legacy classes, which is vector, right? So with So with enumeration, you can only use it with vector. Iterator, you can also use it with ArrayList.
As well as vector.
Vector, yes. But what about the list iterator? Any list implemented classes, you can use the list iterator, right? List iterator is specifically for list implemented classes. List iterator, you cannot use it with a hash set or hash map, right?
No.
But list iterator, you can use it with linked list, with ArrayList, because ArrayList and linked list, implements the list interface, right? That's the conclusion. With iterator also, there is a difference, right? Enumeration and iterator. Can you use enumeration with vector? Can you use enumeration with ArrayList, right? That's also a difference that you have to remember. All right, guys. So right now it's time to wrap up, right?
Yes.
So we have discussed so much. Right now it's already around 1 hour. I don't know. Okay. So if we have if we summarize everything that we have discussed, that basically 4 or 5 points and few extra points that we discussed. Maybe if your interviewer is cross questioning you, or maybe you'll get a question in the counter, right?
Yeah.
So you can also answer those questions. But I always recommend to practice with programs and see what exactly happenings behind the scene, right? But to summarize everything, Ashish, ArrayList performs faster than Vector.
Yeah.
That's what the one line takeaway from this video, right?
Yeah.
And apart from this, okay, synchronization. Okay,
Yeah, all the methods.
all the methods of ArrayList are not synchronized.
And vectors.
Sorry, I'm confusing them. All the methods of ArrayList are not synchronized, but all the methods, most of the methods of vectors are synchronized. The next thing is
ArrayList is not thread safe,
Exactly.
and vector is thread
thread
safe.
safe. Okay. Then the next thing is if the vector is thread safe, explain like a student. If a vector is thread safe, multiple threads cannot operate over the vector object in a particular time. But the ArrayList is not thread safe, so multiple objects can operate over the ArrayList object in a particular time, right? The next thing is based on the performance, as multiple threads are accessing the ArrayList in a particular time, so performance of ArrayList will be better. But in case of vector, if multiple threads cannot operate over the vector object in a particular time, so vector performs slower than
ArrayList.
Obviously it will be performed slower than ArrayList, right?
In case memory consumption, ArrayList is good, but vector is
not good. And the last thing that we discussed is about the iterator. So Ashish, could you please clarify that point?
both enumeration as well as iterator we can use in case vector, and in case ArrayList only we can use the iterator. We cannot
Yes.
use the enumeration in the
Yes.
ArrayList.
And you can also use list iterator to your ArrayList if you want. List iterator,
Yeah,
can
that
use
is fine.
Yeah. Okay.
Okay.
And as you said, vector is slower, ArrayList is faster. And if you are getting this question, which one to use? Tell them I'm going to use ArrayList, over a vector.
Yeah.
And if they're asking why, then already we have discussed so many things. And if they're saying, okay, if I have a concurrent environment and you have to design your application which is going to work in a concurrent environment, at that time you have to say, okay, there are methods in the collection util classes, right? Not classes, collection util class, which is synchronized list. Okay, you can put your list object there, you can make your object thread safe, or you can use Copyonwrite ArrayList. If you're also getting counter question with that, we have already discussed something in our video, and extra stuffs is coming soon. Probably I'll be having Ashish in the future video, and we can also discuss together. If you like this episode, please do let us know in the comment section. And Ashish, you want to say anything to them? Anything you want to say? Okay, so let's wrap it up. Yes. So thank you very much, guys, for watching this video. And Ashish, are you available in the next week so we can shoot another video?
Yeah, I'll try to available.
Yeah. So we can shoot another collection framework video. So collection videos are, collection questions are pretty important in case of a Java interview. So we'll basically try to right now concentrate on the questions coming from the collection framework. So that's it, guys. Thank you very much for watching this video. Hopefully you liked it. If you don't like it, if you are feeling boring, then obviously we'll try to improve ourselves. And please feel free to give some suggestion in the comment section. And also, what is most important is, if you know any other differences, please feel free to put that differences in the comment section. We both will be glad to read your comments, right? Just this is the platform to share knowledge and keep sharing your knowledge, right? Okay, so that's it. Thank you very much for watching this. Hopefully you will have a great day, and happy coding. Stay cool, stay good, and love you guys. Bye bye.